Solve the system of equations using substitution or elimination. Note that some systems may be inconsistent or consistent with dependent equations. We are given the system x plus 2y minus 3z equals negative 9, 3x minus y plus 2z equals negative 8, and 4x minus 3y plus 3z equals negative 13. And I'm going to go ahead and number these equations for discussion, equations number 1, number 2, and number 3. We're going to choose two of the three equations, and by using elimination, knock out one of the variables, which we're going to choose to knock out the x terms or eliminate the x terms. So let's choose equations 1 and 3, and notice if I multiply the top equation, equation 1, by negative 4, and add it to equation 3, I will eliminate my x terms. So let's take the top equation and multiply that by negative 4, giving me negative 4x. Negative 4 times positive 2y is negative 8y. Negative 4 times negative 3z is positive 12z. And finally, negative 4 times negative 9 is a positive 36. And we're going to add this equation to equation number 3. So recopying equation 3, we have 4x minus 3y plus 3z equals negative 13. And we will now add these two equations together. Our x terms eliminate one another. Negative 8y minus 3y is a negative 11y. 12z plus 3z, positive 15z, and 36 plus negative 13 is a positive 23. And that's as far as we can go with that part of the problem. Here we have an equation with two variables, and we'll call that equation number 4. We'll now repeat that process, but instead of using equations 1 and 3, we need to choose two other equations and also eliminate the x term. I'm going to choose equations 1 and 2, and notice if we multiply the top equation, or equation 1, by a negative 3, we'll get a negative 3x, which will eliminate a positive 3x. So let's multiply the top equation by a negative 3, giving me negative 3x. 2y times negative 3 is a negative 6y. Negative 3z times negative 3 is a positive 9z. And negative 9 times negative 3 is a positive 27. And we're going to add that to equation 2, which is a positive 3x minus y plus 2z is equal to a negative 8. And when we add those equations together, notice that the x terms eliminate one another. Negative 6y minus y is negative 7y. 9z plus 2z is positive 11z. And 27 minus 8 is a positive 19. Let's call that equation equation number 5. And now looking at equations 4 and 5, we now have two equations with the same two variables, y and z, so we will make a system of equations out of those two and solve those using elimination and or substitution. So let's go ahead and recopy equation number 4. That's a negative 11y plus 15z equals 23. And now using elimination, we'll go ahead and solve this system of equations. I'm going to multiply equation number 5 by a negative 11. Giving us negative 7y times negative 11, positive 77y. Positive 11z times negative 11 is a negative 121z, and positive 19 times negative 11 gives us a negative 209. We will then then multiply the bottom equation by a positive 7. Negative 11y times positive 7 is a negative 77y. Positive 15z times positive 7 is a positive 105z. And finally, positive 23 times positive 7 is a positive 161. And we will go ahead and add those two equations together. Notice that our y terms will eliminate. Negative 121z and a positive 105z, when we add those together, we will get a negative 16z, and that is equal to negative 209 plus positive 161 is a negative 48. Dividing both sides by negative 16, we get z is equal to positive 3. So there we're a third of the way done. We'll now backtrack and find an equation that has z and one other variable in it. That would be either equation 4 or 5. So let's choose equation 5, and we'll substitute z equals 3 into equation number 5 for z, and that's going to give us negative 7y plus 11 times 3 equals 19, giving us negative 7y plus 33 equals 19. And now we'll subtract 33 from both sides, giving us negative 7y is equal to negative 14. And dividing both sides by negative 7, y is positive 2. So we need to find x yet, so we'll choose one of the three original equations, either 1, 2, or 3. And we're going to choose equation number 1. We'll substitute our value of z in, which was 3, and we'll substitute our value of y in, which was positive 2, and solve that for x. So recopying equation 1, making our substitutions, we'd have x plus 2 times y is 2, or 2 times 2, minus 3 times z, and z is 3, and that is equal to negative 9. X plus 4 minus 9 equals negative 9. Positive 4 and negative 9 make negative 5. That's equal to negative 9. And finally, we will add 5 to both sides, giving us x equals negative 4. So writing this as an ordered triplet, our final answer, x comma y comma z, would be negative 4 comma 2 comma 3, x, y, z. Again, final answer, negative 4 comma 2 comma 3.